Your notes out. Get your notes out right now and title it Congruent Figures. Congruent figures. So congruent figures are two figures with the same size and the same shape. And I know you've heard that before, but we're going to dig a little deeper and find out what that really means. If two figures are congruent, you can slide them, flip them, turn them, and it won't change the fact that they're congruent. Those are called rigid transformations. It doesn't change the size and it doesn't change the shape. So how would you tell if two figures are congruent? That's what we're going to look into today. So the orientation of the figure doesn't matter. These two are oriented differently, but they're still congruent because they're the exact same size and they're exact same shape. So when I think congruent, I think like as far as on my computer, Control-C, Control-V. To me, that's what congruent means. Copy, paste. It's like they're identical. They're the same shape. Are we allowed to assume what? This is just day one of the unit, so yes, there is going to be more. This is just day one. This is just the tip of the iceberg. I have a few slides just showing why it would be important to know if two figures are congruent and where we see congruent figures. Here's an example of congruent pentagons. Those are figures with 5 sides, obviously, and so those are the little wings on the space shuttle. And it'd be important that whoever's checking those or designing those knows how to make congruent pentagons, right? They need to know what congruent means. It means all the sides are equal, all the angles are equal. And if those weren't congruent, then it could have very nasty results, right? Yep, we don't want to get off balance. Here's some other pictures of congruent triangles. Does anyone know where this one is? Good job, Graham. That is the Air Force Academy. I think it's a chapel at the Air Force Academy. Aren't you glad someone knew what congruent triangles were? Because they made that beautiful building out of all those congruent triangles. Isn't that really pretty? Yeah, I think it's beautiful. And then the other one is just showing a bridge and how congruent triangles are supporting the bridge. That bridge is made up of a lot of congruent triangles. All right, so here you go. Here's 5 triangles. Which ones are congruent? Right now you would say, I don't know, because we don't have any information at all. So how would we know? What would we need to do? What are some things we could do to test their congruency? Tick marks, but we can't just start adding tick marks. A ruler, there you go. We could measure the sides, cut it out and put it on top of each other, drag them, measure the angles with a protractor. These are all really good answers. I wasn't looking for one specific answer. To prove them congruent, or to check to see if they're congruent, we would need to measure something. We would need to put the triangles on top of each other. So, like, let's say I was to check, if I was to check this triangle, are you congruent to this triangle? And what would you guys say? You would say no, because even though they're pretty similar looking, they're not exactly the same triangle. So being close doesn't count as being congruent. You have to be exact. So if you were working on a piece of paper and not the smart board, you would not be able to drag these, right? You don't have a smart board on your paper. So what's something that we've used the past 2 days that you could use to check and see if 2 triangles are congruent on your paper? Patty paper, right? You could trace one of the triangles and then drag it over and rotate it as necessary and see if that one fits exactly on top of the other. Papel de Patty, oh my gosh. Okay, so that's how we would know. If one fits exactly on top of the other, perfectly overlapping, we know that they're congruent. So what does it mean for 2 triangles to be congruent? Here's the exact definition. 2 triangles are congruent if and only if corresponding sides and corresponding angles are congruent. So there's 3 sides and it better match 3 sides. And there's 3 angles and they better match 3 angles. So We can't have a definition that's full of this word corresponding and then not even know what corresponding means. So what does corresponding mean? It doesn't mean just like any angle from this triangle has to match any angle from this triangle, right? The same ones, the ones that go together, the ones that match up, those would all be good ways to describe corresponding. So if I had this triangle, and then I had this triangle, pretend that they're congruent, even though they're most likely not. Then if I said, what angle corresponds with angle A? You would say angle R. And so even though if you can't really define what corresponding means, you know what it means. It's the angles that match up, the angles that go with each other, the angles that are in corresponding positions, that are in the same position. Okay? So that's what that means. It doesn't mean that angle A has to be congruent to angle T. That's not what congruent triangles means. Okay, we've spent enough time on that. All right, I want to introduce you to this statement right here. That is called a congruence statement. Say it out loud. Congruence statement.
Congruent statement.
Good. So a congruence statement never lies. Are you listening? You can always trust the congruent statement. The order is going to be perfect. So you always look to your congruent statement for guidance. So if I said, what angle is angle F congruent to? Don't look at the picture, because the picture doesn't have any markings. Look at the statement, and you would say, good, angle C. Because F is listed last and C is listed last. So I now know that F is congruent to C. I wouldn't have known that by just looking at my picture. Trust in congruent statement, yes. And God. Okay, anyways, what about angle A? That one's congruent to angle D. So now I know that D matches up with A, and by process of elimination, let's throw angle E at you. That would be congruent to angle B. So 1, 2, 3. 1, 2, 3. All right, so we trust the order of the congruence statement. So if we switch from angles and we go to sides now, we're still going to trust the order. So if I ask you, what segment is congruent to segment ED? What segment is congruent to segment ED? BA, very good. BA. Because ED is listed second and first. So you choose the one that's listed second and first. Now, is BA the same as segment AB? Does the order matter when you're writing your segments? Some people are saying yes and some people are saying no. Is the collection of points from B to A the same as the collection of points from A to B? Yeah, they're the same collection of points. So even though I would like you to write BA because it would be the same order as ED, I couldn't mark it wrong if you wrote AB. They're the same thing, as long as you have the segment above it. Yes, absolutely. All right, let's try another one. AC is congruent to. Very good. DF. And finally, what have we not done? EF is congruent to BC. Okay, so we could go to our picture and we could add tick marks. AC would get one and DF would get one. And ED, we'd have to go to 2, and then BA would get 2. You get the idea. And that way we know which sides correspond with each other. Okay, next picture. Now we're going to flip it up on you. Now I'm going to give you the figure with the markings, and you have to give me the congruent statement. And the order does matter. The order does matter. So I'm going to name the first triangle. I'm going to name it triangle TNU. Now you need to name the second triangle appropriately. Is it Jim? Is it Meg? Is it Mug? Okay, I can't fool you guys. It is. It is Meg. It almost spells nutmeg. Get it? Like, use nutmeg in November when you're making apple pie and pumpkin pie. Nutmeg. Haha. Okay, anyways. So when I named T and U, I started at T. I went across 1 tick mark, and then I went across 3 tick marks. So that means I better do it again. I better go across 1 tick mark and then across 3 tick marks. So I better go across 1 and then across 3. So I better start here and head in this direction. M-E-G. Does that make sense? Because you could get the whole problem wrong by just putting the wrong order. T-N-U is congruent to M-E-G. All right, try this one. Let's not type it yet. I'll tell you when to type it. Just have it ready. What? Okay, so when I named X, Z, Y, take a look. X has 3 arcs. 3 arcs. Z has 1 arc, and Y has 2 arcs. So I went 3, 1, 2. So I want to go 3, 3, 1, 1, and then 2. And I can see that we all get it, right? So we can keep going. Okay. All right, now let's actually solve for something. Given triangle ABF is congruent to triangle CDE, find the missing measurements. I'm going to give you a minute and then I'm going to call on you. All right, so Graham said that AB is 6, and he should have put centimeters, but that's okay, I'll forgive you. 6 centimeters, and the measure of angle ABF, Chloe said, was 67. Oh, we don't put degrees when they have the M for measure. Real quick, let me discuss something. This AB equals is completely different from this. I want you to look at those two. Do you see the difference? Because students get really confused about this. The top one is saying segment AB is congruent to blank. You're supposed to answer with a segment. The next one says the distance from A to B equals, that one's asking for a number. So my students get really confused about whether to put a segment or whether to put an answer like a number. And so equals means number, congruent means segment, symbol. Lars? Okay, since AB is congruent to CD, CD is 6, therefore AB is also 6. How did we get angle B right here? How did we get this angle? Well, first we had to look at our congruent statement and say, oh, angle E matches up with angle F. Angle E is 85, therefore angle F is 85. And so then we just use triangle angle sum theorem, and we add up 28 plus 85 and subtract it from 180. And that's how we get angle B. So that's how we got 67. All right, next example. If angle ABC is congruent to triangle DEF, triangle ABC is congruent to triangle DEF, angle B is x plus 40, angle E is 2x minus 10, and angle D is 40, solve for the missing values. You will see one like this on a quiz, maybe even on the test. And you need to know what you're going to do with those equations. What's your game plan? Are you going to set some of them equal? Or are you going to add them to equal 180? So to figure out your game plan, you need to look at the picture. Angle B is x plus 40. Angle E is 2x minus 10. And angle D is 40. Now let's see who's congruent to who. Who's congruent to B? B is listed second, and E is listed second. E and B are congruent. They're the same angle. And angle D matches angle A. And then, so that would mean angle F matches angle C. Sometimes I do that to match them up. I circle one pair, I underline one pair, and I square the other. Anyways, you are not going to add those three to equal 180. You don't have one of each. You don't have a circle, an underline, and a square. Two of those are congruent. B is congruent to E. So you're not going to use the 40 to solve for x. x plus 40 equals 2x minus 10. We are not using this in our equation. You don't have to use everything you're given. So Adriel, what do you get when you solve for x? All right, so x is 50. And then we can plug it in. 2 times 50 minus 10. Ganesh, what'd you get? 90, very good. So obviously our triangles are not to scale because those are right triangles and they surely don't look like it. And then the measure of angle F. Alton, what'd you get? Okay, I'll just keep working it. Measure of angle F would be 50 because when you plug it in, you get 90 and you've got 40 and 90 and you subtract it from 180 and you'll have 50. Okay, next problem. I'll start off the congruent statement for you. Triangle FBR is congruent to triangle blank. So this triangle has definitely been rotated, right? This one has been taken and kind of rotated. You couldn't really see what I did, but what I would do first is maybe find the missing angles. So look at triangle FBR and find the missing angle. 90 plus 58, subtract it from 180. That missing angle is going to be 32. And then you can look at this other triangle. Look at that triangle. 90 plus 32, subtract it from 180. Oh, looky there. You get 58. So those two triangles are congruent. They have all the same angles, which doesn't prove them congruent, but we'll learn about that on Thursday. Just trust that they are congruent. And so angle F is going to go with angle E because they're both 58. Angle B is going to go with angle R because they're both 90. And angle R from the one triangle is going to go with angle L from the other triangle. We'll spell Earl. Yeah. Okay, so now let's find all the missing angles they're asking about. Angle FRB. Well, we found that when we were trying to decide which angles were corresponding. So we already found that one. It's 32. Angle LEB. This angle. Well, we already found 58, so now we just need to find the linear pair to 58. 122. And then LRF. This angle right here. Well, we know angle R is 90 degrees, so 90 minus 32, and we'll be back at 58 again. Okay? If pentagon paint is congruent to pentagon house, find the false statement. So you're looking at the order. This question is completely about order. You're saying the third one? Very good. So take a look. AI is listed second and third. But US is listed third and fourth. So that one is the false statement. Very good. Last example. If quadrilateral QRST is congruent to quadrilateral ABCD, what are the coordinates of D? So all you have to do is just make sure that those two quadrilaterals are identical. So what I would do is I would say, hey, how do I get from S to T? Because it doesn't look like it's been flipped or anything. It looks like AB is the same and BC is the same. It looks like it's just been translated. So we're in good shape. So I would just find the slope from S to T. You rise 1 and you run 1, 2, 3, 4, 5. So I'm going to go to C and I'm going to rise 1 and run 1, 2, 3, 4, 5. And then it's our coordinate of D. And now we've got two congruent figures. Hopefully. Yes. All right. Oh, so what are the coordinates? Wait, we have to name the coordinates. 1, 2, 3, 1, 2. So 3, -2. How do we know they're congruent? Oh, because it told me. It said if they're congruent, what are the coordinates of D? Okay. The last thing is, what is this called? I made you say it earlier. A congruent statement. And it is always true. All right, that's all for today. Bye.